Hello and welcome to Adding and Subtracting Radicals. The goal for this is to combine like terms. Like terms mean radicals. Like radicals have the same index and the same radicand. So you could say that the 7 radical 3 and 5 radical 3 are like radicals and can be added or subtracted because they share the same radical 3. When adding and subtracting radicals or the coefficients, the radicals remain the same. So it's kind of like adding fractions and then you keep the same denominator. If they have the same denominator, you can add them, then you keep it. So I'm looking at some examples. We have for number 1, 7 square root of 3 plus the square root of 3 minus 8 square root of 3 minus 5. If you look, these first 3 terms all share the same radical 3. Knowing this second term has a coefficient of 1, so we can add 7 plus 1 gives us 8 square root of 3 minus 8 square root of 3 minus 5. So these two can be brought together, giving us 0 minus 5, or just minus 5 as our answer. Looking at number 2, we see that these two share the same features because 7 square root of 2 minus 10 square root of 2 plus 6 square root of 5, these square roots of 2 share the same thing under the radical, so they can be brought together. The 7 minus 10 gives us minus 3 square root of 2. Let me just bring the 6 radical 5 down because it cannot be simplified or added because it does not share similar terms. Number 3, if you look at that, you see that nothing can be brought together because they all have different terms, so this is already simplified. Simplified already. Okay, looking at number 4, we can see that 19 minus 4 square root of 2 minus 5 square root of 2. If you look, these two share the same square root of 2, so we can just bring the 19 on down and have our square root in the answer, so that stays the same. So we have minus 4, minus 5, or just a minus 9 as our answer. Making the note, if radicals are not like, check to see if each radical can be simplified first, and then check to see if like terms appear. So this is actually going to deal with simplifying radicals to see if they're hiding what we're looking for. So examples would be to add or subtract as indicated, simplify each radical first, and then combine like radical terms. So these two are not the same on the first appearance, but no, the square root of 12 can be thought of as the square root of 4 times 3, which can be brought down even farther as the square root of 4 times the square root of 3. Know that the square root of 4 can be broken down as 2, and they just bring down our square root of 3. We're going to have our plus in each instance. And now let's think of the square root of 27. Square root of 27 can be thought of as square root of 9 times 3. 9 is a perfect square, so it can come out after breaking these apart. Knowing the square root of 9 is 3. And we're going to leave our 3 into the radical because it cannot simplify any further. Now if you look at these, they share the same like term of radical 3, so these can combine together. The coefficients of 2 and 3 is 5 square root of 3. Looking at number 2, we have 5 times the square root of 12 plus the square root of 27. So we should have a lot similar answers since these appear very similarly. So we have 5 times the square root of 12 broken down into 4 times 3. So we have 5 times the square root of 4 times the square root of 3. Again, the 4 can be brought out as 2. Then we have our times the square root of 3. So we can simplify this part right here of 5 times 2 as 10 square root of 3. You're going to be adding the square root of 27. So square root of 27 can again be thought of 9 times 3 under the radical. We break these two multiplications apart, knowing 9 is the square root, making it 3, having our square root of 3, breaking it down of 3 square root of 3, and since we have common terms of square root of 3, we can combine the 10 and the 3 to be 13, and then leave our square root of 3. Looking at example 3 and 4, we have that 3x minus 8 times the square root of x squared plus 2 square root of x. So we need to think of x squared coming out of the radical, and since it is a positive number, we can think of it as our old rule of exponent divided by index in this case. So we have our power is 2 over the index of 2, just leaves us with 1. So we can actually pull this out of the radical, this leave our 8 there, times our x to the power of 1, or just x, plus 2 square root of 2 of x. So now you might be tempted to say, what can I do anything with this 2 square root of x? You cannot, because that is a power of 1 and it can be broken down any farther. It is stuck right there. But as you notice, if we make it a bit more legible, we have 3x minus, this simplifies to 8x plus 2 square root of 2. So now we can think of these having like terms. So we just have negative 5, because 3 minus 8 is negative 5. Leave our x in there, plus 2 square root of x is our final answer. With number 4, we can't really see anything looking above as coming together yet, but we can think of 25 coming out of the radical as 5, so it can come out as 5. So we're going to have to multiply by 2, and that x will have to be left in there because it cannot be simplified any further. So on this point, 2 times 5 is 10 times radical 2. I have our plus. And we look at 64 as the square root, resulting in 8. So we can actually pull 8 out here, and there was a 1 already coefficient, so we have our 8 on the outside, leaving our radical 8. And here the square root of x we're not able to do anything else with, so it just comes along for the ride. And if we simplify this middle term right here, 1 times 8 is 8 square root of x. And if you pay attention, they all share the same radical x. So you are now ready to simplify, leaving our radical x involved. So we have 10 plus 8 is 18, minus 5 is 13. So our answer is 13 radical x. For our final example, for this we have the radical of 5 minus 16 minus 5 over 64. What I would recommend doing first is breaking each piece down. So we have the radical 5 divided by radical 16 minus radical 5 minus radical 64. Okay, radical 5 won't go anywhere because it's a prime number. It's not broken down into any perfect squares. But if you look, 16 is and you take the square root of that, you have 4. And on the other side, we have the square root of 5, which won't go anywhere. But 64 can actually be broken into the product of, you can actually think of 64 taking the square root of that, and you're left with 8. So to simplify this, you need to get common denominators, and to do that, you need to know that this common denominator between these two would be 8. So to get common denominators, you can leave this second term as it is, but if you multiply this by 1 in the form of 2 over 2, you're going to get 2 radical 5 over 8, because if you just multiply each piece by 2, and you simplify, keeping the denominator of 8, you have 2 square root of 5 minus square root of 5. If you pay attention, there's a 1 right there on top. So you're going to be left with 2 minus 1 is 1. So square root of 5 over 8.